Hello everyone, welcome to our new video in which we are going to learn preparation of phenols. Our chapter going on is alcohol, phenols and ethers. So the first method of preparation of phenols is from chlorobenzene, Dow process. Remember my friend, this question was appeared in HSC board exam 2023, March 23. Okay. So question can be asked, how will you prepare phenol from chlorobenzene or explain Dow process of preparation of phenol. So first of all, we have to draw the structure of chlorobenzene, that is benzene ring and chlorine is attached. Then on there we had NOH which is a base. So we are adding base to chlorobenzene at 623 Kelvin and 300 atmospheric pressure. So what will happen? It will this NaO group will attach to this benzene ring like this, O minus Na plus, and this Cl and H will remove. We are not writing HCl here. So what we will get? O minus Na plus and benzene means sodium phen oxide. Why? Sodium is there, phenyl ring is there and oxygen is there. So sodium phen oxide we are getting, and what is removing out? H and Cl. So that HCl is there. So again we are adding that HCl, means first of all we have added the base. So we got the sodium phenoxide, which is the conjugate base of this dilute HCl. Dilute HCl is an acid and it is a conjugate base which contains Na plus ions. So dilute HCl is there. It means acid contains H3O plus ions. Remember, acid always contains H plus or H3O plus ions, and base will contain OH minus. By combining, then we will get H2O, and here we will get 2H2O. Okay. So H3O plus means addition of acid. It shows the addition of acid. So what will happen? Again, this hydrogen will go there. So it is a phenol, and NaCl will removed out. Okay. So we will get the phenol. Our next process is from cumene, or which is also called as commercial method of preparation of phenols. Question will be asked, how will you prepare phenol from cumene, or how will you prepare phenol from isopropyl benzene? Cumene structure is this, isopropyl benzene. Or what is the commercial method of preparation of phenols, or how will you prepare phenol and acetone from cumene? Any question can be asked. Now see, this is cumene. Cumene means isopropyl benzene. Benzene ring is there, and propyl means 3 carbons. Iso means it is attached to the middle carbon, and 2 CH3 groups are there. Plus on air oxidation. Oxidation means O2. So we are adding 2 oxygens in the presence of co-naphthenate solvent at 423 Kelvin temperature. So what will happen? These 2 oxygen will be added here like this. This CH3, this CH3, I am writing there as it is, and between this carbon and hydrogen I am adding these 2 oxygen. So it is cumene hydroperoxide. And now on addition of dilute HCl and heating, we are getting phenol and acetone. How we will get the phenol? This total group will get removed and this OH will attach to the ring. So we will getting phenol. And this total group means carbon is there, CH3 is there, CH3 is there, and 1 oxygen is there. So eventually it is like this. But carbon's valence is 4 and we are only making 1 bond, and oxygen also needs 2 bonds to for being neutral. So double bond will be present here. So it is called as acetone and it is called as phenol. Why it is called as commercial method? Because we are getting 2 valuable byproducts. That's why it is called as commercial method of preparation of phenols. Now we will move forward to our next concept. Our next reaction is preparation of phenols from benzene sulfonic acid. See, benzene from benzene sulfonic acid. So benzene ring and SO3H group attached to the ring is called as benzene sulfonic acid plus NaOH. So NaOH is a base. So what will happen? it will form sodium benzene sulfonate. How? This Na will attach to the SO3 group and this hydrogen will come here. So HOH means H2O. H2O is being removed and this Na is getting attached to the SO3. So it will become SO3 minus Na plus and it will become sodium benzene sulfonate. So SO3 minus Na plus. Again we are going to add NaOH at 573 degree Kelvin. So again we are adding the base and we are getting sodium phenoxide. So again SO3 minus and Na plus will get removed from this structure and O minus will shift here and O minus and Na plus will remain. So what will remain? Sodium phenoxide. As we all know, Na plus, O minus and sodium phenoxide. Now on addition of dilute HCl, same reaction as the first reaction or the Dow process. Now on addition of dilute HCl, we are getting the phenol. OH ring, OH group is attached to the ring. Now next is from aniline. Aniline can be called as aminobenzene also because NH2 is there. Generally ammonia means NH3. But now N has to attach to the benzene ring, so it will remove its own hydrogen and it will become NH2 and it will attach to the benzene ring. So what will happen? Aniline will react with nitrous acid. Nitrous acid. HNO3 means nitric acid and HNO2 means nitrous acid. Nitrous acid is combined by NaNO2 plus HCl. It will give HNO2 plus NaCl. That is the reaction of nitrous acid at 273 degree Kelvin. So what will happen? This nitrogen will attach here, so it will become N2 and this Cl minus will also attach there. So N2Cl and it will become benzene diazonium chloride. Why diazo? Because two nitrogens are there. So it is diazo group, benzene diazonium chloride. Now on a hydrolysis, hydrolysis means addition of water. On a hydrolysis means addition of water. What we are getting? OH group is attached, so we are getting phenol. Hydrolysis means H2O means nothing but 8. H2O is nothing but H and OH atoms. So hydrogen is there, OH is there. So what will happen? This OH group will attach here. This N2 will remove separately like this and this remaining Cl minus and HCl will be here. So it is the reaction from aniline, preparation of phenol from aniline. So these reactions was for preparation of phenol from aniline. Now we will move forward to the physical and chemical properties of the alcohols and phenols. Our next concept is arrange OH, CH and NH bonds in increasing order of their bond polarity. Now, the bond polarity is depend upon the electronegativity. How electronegative the atom? So it will be depend upon the bond polarity. Bond polarity will depend upon the electronegativity. So electronegativity of oxygen is higher than nitrogen and it is higher than carbon. So carbon has the lower electronegativity and oxygen has the higher electronegativity. So simply bond polarity also will increase from CH, NH and OH. So this is our answer. So our next topic is physical properties of alcohols and phenols and the first one is nature of intermolecular forces. शूटिंग होता है ना physical properties of alcohols and phenols. So the first one is nature of intermolecular force. This is our first physical property. So nature of intermolecular. Intermolecular means suppose this is the molecule of alcohol as we all know ROH. Now the whole alcohol, as we see in day-to-day life, or it is useful, it is not only made by only one molecule, it is the combination of many molecules of alcohol. So what will happen, this alcohol molecule will be attached to another alcohol molecule, and number of alcohol molecules will be attached to each other. But how they are getting attached? This oxygen will have partial negative charge, delta minus. This hydrogen will partial positive charge. They are attracting each other. Similarly, delta plus, delta minus. So this delta minus and delta plus, positive negative, will attract each other, and they will form an intermolecular attraction or intermolecular force. This is called as intermolecular hydrogen bonding. Hydrogen bonding. It is in the case of alcohols. Now, similarly, in phenols, what we observe, phenols means an aromatic ring and OH group is attached. Again, oxygen and hydrogen, oxygen having delta minus, hydrogen having delta plus. Similarly, one more phenol group I am going to draw here, aromatic ring and hydrogen delta plus, oxygen delta minus. So simply this delta plus and delta minus will attract each other, and this is again called as hydrogen bonding. This is called as intermolecular hydrogen bonding. That is for phenol. This is for alcohols. So this was the first one, nature of intermolecular force. They both are attracted. Two molecules of phenols or two molecules of alcohols are attracted towards each other by hydrogen bonding. Okay. Our next topic is physical state. So now see, physical state of lower alcohols are generally colorless liquid which are toxic. Uh, uh, this is for alcohols, and phenols are also colorless and toxic, and which have a carbolic smell. This is the physical state of alcohols and phenols. Our next topic is uh, boiling points. So boiling points chart I am posting here, and we will solve one problem regarding to that chart. That chart will be here. I will edit the chart and keep it here. Now we will solve the problem which is given in our textbook. Okay, let's go.